This problem presents us with an underdetermined system. We have two equations but three unknowns, x, y, and z. It's actually the first two equations that we saw in the previous example. We want to solve this underdetermined system for x and y in terms of z. And again, we'll be using Mathematica to do so. So going into the Mathematica, I can put in my two equations. So I'll be doing the variable form of this, so putting into this equations variable my list of now two equations, x plus 2y plus 5z double equals 4, and 2x minus 3y plus z double equals negative 4. All right, so those are my two equations. And I can use that same solve command I used in the previous example. So I give it the list of equations I want it to use. And now it's important here I tell it what to solve for. I am giving it the list of variables to isolate on the left-hand side. I only have two equations, so I can only put in two variables here. Well, it'll be x and y. So this will guarantee that's going to give me an x equals equation that does not have y on the right-hand side, but it will have z and constants, but that's okay. And an equation where y equals something, but that right-hand side won't have x in it. So these variables will be by themselves after this solve command. And that's it. I can run this. And we see what it gives me. X equals, now again, it's trying to have it as exact an answer as possible. So this 1/7 4 minus 17z. So z is on the right-hand side. That's okay. Since there's only one solution, I can make this look a little bit nicer. And a y equals equation. So y equals negative 3/7 times negative 4 plus 3z. So z is on the right-hand side and constants, but x and y are by themselves. Just like with the unique solution, like we saw before, I can get this in decimal form various ways. So now it does the decimal equivalents or decimal approximations of the solution. Or, again, with that n at the end, is going to give me somewhat the same result. Here it's still in decimal form, but tried to factor it as much as it could. So depending on what you want your solution to look like is which commands you want to use in this solve. Do you want numerical solve, NSolve, or do you want this //n until it looks the way you want it? And going back to the solve, if we wanted it to be a little bit more clear what we're doing, if I didn't use this equations here, or x here, I can put in my individual ones and see here, it gives us a little visual clue of which are the variables that are going to be solved for and what's going to be left over. So x and y have turned teal, while z is still this blue. So there is sometimes an advantage of not putting our list of equations into that variable so we can see what's happening in the solve command, and then we can run it. But just be aware of the different options that Mathematica is going to give you. There is not going to be just one way to input the problems that we have that we want it to solve.